Hey everyone, today we're going to learn how to balance redox reactions, and we're going to split this into part 1 and part 2. And today we're going to learn how to balance them in acidic conditions. So before we can balance redox reactions, we have to do a little recap on half reactions. Remember, to write half reactions, typically you are given a reaction, you will split it into the two half reactions. For example, manganese is going to pair up with my manganese over here, and carbon and oxygen is going to pair up with my carbon and oxygen over here. The first thing that we're going to do is we're going to balance the number of atoms first, and if we're having trouble balancing oxygen or hydrogen, we can use water or H plus because we assume that these take place in aqueous conditions. Second, after we balance the atoms, we're going to balance the charges using our electrons. Now, I wrote this on the last lesson. I'm going to write it again. We're going to add electrons to the most positive side. And that is because electrons have a negative charge, so they're only going to bring things down. If we are going to recap on an example that we did last week, so this should be in your notes. Here we have one manganese, but I have 4 oxygens on the left. So in order to balance this, I'm going to put 4 oxygens on the right. Now I need to balance my hydrogens. Here you're going to see I have 8 hydrogens, so I'm going to add 8 hydrogens to the left. Once you balance out your atoms, we need to make sure that we balance out our charges. Here, 8 minus 1 gives me a 7 charge over here and a plus 2 charge over here. So last week we learned to add 5 electrons here to bring that 8 down to a 2. Or that 7 down to a 2. My bad. And now it's completely balanced. Then what we did was we balanced the second part of that reaction. Here I have 2 carbon. Over here I only have 1. So we can first try to stick a 2 out front and see if that works. We're going to notice now we have 4 oxygen and 4 oxygen, so that indeed helped us. We didn't have to add water or hydrogen ions. But we do still need to balance the charges. Here, this side has a negative 2 charge based on my compound, and this one has a neutral charge. To bring this 0 down to a negative 2, we added 2 electrons. If you remember how to balance half reactions, that's perfect because it's going to lead into what we're doing today, which first step is write the half reactions for the given equation. Second, we're going to adjust the coefficients so that both half reactions have the same number of electrons. The reason we want to do this is because we want the electrons that was lost by one reaction to be the same amount that was gained in the other reaction. Once we have them both have the same number of electrons, we're going to combine these half reactions. That means substances on the same side of the arrow are going to add together to be in my final equation, and things on opposite sides are going to subtract and potentially cancel one another, then going in the final equation. Lastly, we are learning how to do these in acidic conditions, so we must understand that acids have always increased my H plus concentration, while bases have increased my OH or hydroxide concentration. If there were H plus ions in your balanced equation, it's considered to be under acidic conditions, and you do not have to take any further steps. So let's carry on that example we started at the very beginning. So here are 2 that we had for our half reactions. What we need to do is learn how to adjust the coefficients so that they both balance and have the same number of electrons. First thing, we need to note that this one has 5 electrons and this one has 2. So we need to think of a common multiple that it can reach. And the one off the top of my head is 10. So in order for them to get 10 electrons, we're going to take this entire top equation and multiply it by 2. And we're going to take this entire bottom equation and we're actually going to multiply this bottom one by 5. So what I'm going to do is I'm going to kind of rewrite these equations with their new coefficients. Here I have 10 electrons, 16 hydrogens, plus 2 MnO4s. And this is going to yield that 2 gets carried over 2 manganese ions plus 8 water. Then I'm going to redistribute this 5. So 5 C2O4, 2 negatives, 10 CO2s plus 10 electrons. That is what I mean by adjusting the coefficients. Once you adjust the coefficients, we can actually just combine the half reactions. Remember, substances on the same side of the arrow are going to add together, and substances on opposite sides are going to subtract. Here we're going to note that my 10 electrons are on opposite sides. They are going to subtract. There's nothing else that is the same on both sides. So then we're just going to add those together to go into our final reaction. So our final reaction ends with 16 hydrogen ions plus 2 manganate plus 5 C2O4, 2 negative, yields 2 Mn2 plus 10 CO2s plus 8 water. We're going to note that I have excess H plus ions, which means this does take place in acidic conditions. The last thing that we really need to make sure of is that our coefficients cannot be reduced. So if they can be, we need to make sure we reduce them. Since this is a 5 here, nothing can reduce it for what I've given, so I'm the smallest, and this would be my final answer. Let's try to do that with another example. Here, we need to separate it into the two half reactions. So chromium with chromium and iodine with iodine. So here, Cr2O7, 2 negative, yields Cr3 plus. First thing we need to do is balance our atoms when writing our half reactions. On the left-hand side, I have 2 chromium, so on the right, I'm going to put 2 chromium. I have 7 oxygen, so to balance that, we're going to add 7 waters. That throws off my hydrogen, so 7 times 2. I'm going to add 14 hydrogen ions over here to the left. The next thing that we need to do is to make sure that our charges are balanced. So 14 times positive 1 is positive 14, minus 2 charge from here gives me a 12 charge. Over here, I just have a 3 positive. So in order to bring my 12 down to a 3, I can actually add 9 electrons over here to the left-hand side. Now we can move on to the next half reaction. We have iodine and then iodate. Notice my iodines are balanced, so we need to balance out this oxygen from iodate. So we're going to actually add 3 waters over here. And then to balance that water, we're going to add 6 hydrogen over here because 3 times 2 is 6. From there, we need to balance our charges. Over here on the left-hand side, our charge is -1. On the right-hand side, 6 minus 1 gives me 5. So I need to go from a 5 to a -1, and we do that by adding 6 electrons. Once you get your half reactions, we need to make sure that our electrons are the same. So our most common easy multiple to reach with 9 and 6 would be to get them both to 18. Again, the easiest way to get 9 up to 18 would be multiply it by 2. And then to get 6 to 18, we're going to multiply everything in its equation by 3. Then we're going to rewrite these with their new multiples. 2 times 9 gives me 18 electrons plus 28 hydrogens plus 2 Cr2O7, 2 negative, yields 4 Cr3 plus 14 H2Os. Then we're going to distribute my 3 here. So we're going to notice that I have 9, because 3 times 3 is 9, H2Os plus 3 iodines, 3 iodates, plus 18 hydrogen, plus 18 electrons. Now that I have my electrons are the same, remember we can cancel what is the same on both sides. So 18 and 18 electrons cancel. We also have water on both sides, so they're going to simplify. We're actually going to get rid of these 9, and then 14 minus 9 gives me 5 water left over. We can also eliminate hydrogen. So this hydrogen gets eliminated, and then 28 minus 18 gives me 10 left over. Doesn't look like anything else can be simplified, so I can just rewrite everything for my final answer. So you're going to notice you get 10 hydrogen plus 2 chromium yields 4 chromium plus 5 water plus 3 iodates. And here, if you were to recheck this, your atoms would still balance and your charges would still balance. And it would be under acidic conditions because we have a hydrogen ion right here. And this is the last example. If you guys would like to pause the video and try it on your own, you are more than welcome to. If not, let's go through the answer. If we were going to split these into the half reactions, tellurium is going to go with tellurium, and nitrogen and oxygen, of course, are going to go with the nitrogen and oxygen. So from here, we're going to split it into our half reactions. TeO3 to negative, turning into Te. We're going to see that tellurium is balanced. So to balance out this 3 on oxygen, we're going to add 3 water. And then we're going to add 6 hydrogen on this side to balance my hydrogen on my right. From there, I need to balance my charge. On the left, this side is neutral, but this one's 6 times 1, 6, minus 2 gives me a 4 on this side. So to balance it, I'm actually going to add only 4 electrons on the left-hand side. To balance the second half reaction, again, we have N2O4 and then NO3, negative 1. Now, because of this, we need to match up our nitrogens. Here I have 2. So to get 2 nitrogen, I'm going to stick a 2 out front. But we're going to notice that our oxygens are off. Here I have 4 oxygen, but 2 times 3 gives me 6 on this side. So to get 2 more oxygen, because 6 minus 4 is 2, I'm going to add 2 waters only. That gives me 6 oxygen on the left and 6 oxygen on the right. Because I only added 2 waters, I only need to balance out 4 hydrogens, so that's what we did. From there, we need to make sure that our charges balance. Here, this side is neutral of 0. This one is 4 minus, and then there's a 2 out front, minus 2 gives me 2 on this side. So I have a positive 2 and a 0. To bring that positive 2 down to 0, I'm going to add 2 electrons. Once you guys get your half reactions, we need to make sure that we change the coefficients so our electrons equal. Our most common number between 4 and 2 is actually 4. So you actually only need to multiply the bottom equation by 2 in order to get your final answer. So what I'm going to actually do is just rewrite the top one as well. It helps keep me organized. But of course, you guys don't have to write the top one if you guys don't want to. For me, it just helps to keep it all straight. Now I'm actually going to distribute my 2 on my bottom one. So we're going to see that I have 4 H2Os plus 2 N2O4s yield 4 nitrates plus 8 hydrogen plus 4 electrons. Now that we've done this, we can cancel what is the same on both sides. So we're going to see that my electrons cancel here. We're going to see that 3 of these hydrogen will cancel 3 of these hydrogen, so that leaves me with just 1. And then here we're going to see that I have 6 hydrogen, and that's going to get rid of 6 over here, so now I just have 2 H plus ions. From there, we just write what we have left over. So we have a water left over. We have dinitrogen tetraoxide, and we also have TeO3 negative. This is all going to come out to be tellurium plus 4 nitrates plus 2 H pluses. Again, what we're going to notice here is that our charges actually end up balancing. So do our atoms. And so this would be considered a balanced equation, and it's happening in acidic conditions because I have an H plus ion as part of this equation. So again, there's example number 3. That's the end of today's lesson. If you have any questions, please make sure you ask. And otherwise I hope you guys have a great day.